Hi everyone, Ramadan Karim, and welcome to our third session of 5G with Karim Rabie. Today we'll be discussing 5G deployment and migration. Just to recap, in the first session we covered the road to 5G. We covered all the three GPP releases, starting from release 96, 97, then 7, 8, 9, 10 till 15 and 16. We also covered the ICT requirements from 5G, the drivers. And on the second session, we discussed more some of the use cases, enhanced mobile broadband, and also the increased bandwidth. Maybe we're expecting around 750 gig per kilometer. And we discussed how to achieve this requirement on the RAN, core, transport, and all the other layers, like even the terminal itself. So I'm happy to have you again, Karim, in our session. I'm sure it will be an exciting one, similar to the previous one. So without further ado, I will give you the mic.
Ramadan Karim for all. And I'm very happy to be here for the third time. And this time we have some of our colleagues with us. So I think it will be interactive. It will be a little bit different from the other sessions. Okay. So the topic of today is the 5G deployment options and the migration. So though it looks like a basic topic, but I see it's a very important subject because that's actually the foundation of any 5G rollout. Okay, you have to know exactly what kind of deployment option that you are targeting and how you are going to reach that. And we end up with the some sort of comparison between the concept of the vRAN, ORAN, and cRAN, because I know that there are a lot of terminologies in the market. So we have just one holistic view of the technologies. We will try to explain the concept. So let's start. I'd say go to the agenda. So these agendas, the 5G deployment models, and the migration for 4G to 5G, and the vRAN, ORAN, and the cRAN. At any time, if you have any questions, to I'll drop a message maybe, and Radwan can read it or maybe stop me. So
Yeah,
I think
you can
okay.
mention Karim. So maybe just drop your question on the chat, and I will take a note and yeah, repeat it here for everyone.
Okay. So since the start of these sessions, I always had some standard figures, standard drawings, so from certain organization, just to give always a reference from what we are saying. So this time we have this kind of map from the GSMA, and GSMA is the GSM Association. It's a very well-known organization, and if people here are familiar with 3GPP, so GSMA is one of the I would say market partners for 3GPP. So GSMA is the one who brings the market directions, the some sort of guidance for the technological evolution for 3GPP. So there are a lot of cooperation between GSMA and 3GPP. So if you see this this map, it looks like, I mean, let us read it together. What are these terms? So
Karim,
there is nothing presented.
we cannot see your screen, Karim. Still is the first slide. Yeah. Now just move to the agenda.
No, but this is not the sign, right? Let me, okay, if it happens again, let me change the connection, okay?
Yeah.
So you see now the 5G deployment?
Yes, the deployment model was still in the title.
And you don't EPC 5G cover. You don't
Nothing. Nothing. No.
Not yet.
Okay. give me a minute. I will do something here.
Yeah, now it's now I can see it.
I have to just change the connection, okay?
Okay.
Okay, can you see it now?
Yes.
Okay, that's good. So what we can see now is some sort of a map that includes some options, okay? Let's try to read these options together. I mean, without any relations between each other. Just try to read what is mentioned there. What is this diagram? So you see in the first row, there's something called SA, and there are some options. So it seems that the common thing between these options that it's a single radio solution. So it's either you have like LTE, which is the 4G radio connected to EPC, or a new radio, which is the 5G radio with a 5G core, or a hybrid mode with LTE connecting to 5G core. So this SA is called standalone. So from the diagram and from the definition, it's the deployment where you have actually like a single radio. Okay, it's either 4G or 5G. And when we try to interpret the NSA, it seems that the thing common in the option 3 and 4 and 7, regardless what are options 3 and 4 and 7, that the existence of dual radios or two radio stacks, which is the LTE and NR, with different combinations. And that's actually the definition of the NSA. So the NSA, it's a deployment where you have dual write or multiple radio access technologies, which is 4G and 5G. So if we start scanning the options on a high level, okay, so you see there's a column called EPC and another one called 5G core. So it seems that in this set of options, you have still the old EPC. And for these new options, you have the 5G core. So starting from option 1, and it is in gray for a reason, it's the LTE radio, which is the E node B, connected to the evolved packet core or the EPC. So that's actually the current case, right? That's the 4G standalone deployments, where you have E node B connected to MME as gateway, P gateway. And it seems that option 2, it's similar to option 1, but in 5G environment. So that's purely the new radio, the 5G radio connected to the 5G core. I can interpret this line that it is a combination of control plane and user plane. So that means that new radio is connected to 5G core via control plane and user plane. And in option 5, that's the LTE E node B, the old radio connected with the same interface or similar control plane user plane to 5G core. If you go to the NSA options, I'm just trying to read the diagram. So it seems that in option 3, the two radios, the new radio and the LTE, will coexist, and both of them will be connected to the EPC. Okay, so it seems like a transient step where you have LTE and EPC, and you start to introduce the new radio. So that's the new brick from the 5G here, which is the new radio. If you go to option 4 and option 7, so it seems that the change here is that we have introduced the 5G core. So the 4G core, the EPC is not there anymore. And we have a combination of NR and LTE. And in option 7, it is somehow reversed LTE and R. So what is the difference? It seems that in option 4, okay, and in option 7, the anchor point, or the one that is actually connected to the 5G core with the control plane, it's different. So if I read option 4, it's written like new radio and LTE, and in option 7, it's written LTE and new radio. So I can interpret initially that in option 4, the new radio is the anchor point for the control plane. So the control plane is coming from new radio to 5GC, and in option 7, the control plane or the anchor point is coming from LTE to 5G. So that's just, reading the diagrams. Okay, what do they mean?
Great, so just let me stop you here. So when we just from nutshell, and when we grasp this diagram, maybe 2 points will come into our minds. First one, why we have option 1 as part of the 5G deployments, because it's more like a historical option and it's purely 4G. Second option is second question is why option 6 as example is not there in the on this option in this diagram.
Okay, yeah. So let me answer that. So initially the 5G deployment is not basically a greenfield, right? Except for some operators like Rakuten, like Dish in USA, but we are always moving from brownfield, right? So the starting point for us is the EPC. That's why the GSMA believe that it should be there as an option one, and you will see now that we will move from option one to other options. Okay. For the other questions, this brings the question. Okay, who actually invented these options, right?
Great, yeah.
So the options were suggested by Deutsche Telekom. Okay, in the initially like as an options for deployments. And as we go, there are some adoption from some standardization standard organizations. So okay, so some options are getting popularity, and they started to be a mainstream, and some options are being dropped. Okay, one way or another. Okay, so you see now that, for example, option 5 is not that popular, right? So it's not there explicitly in 3GPP. So 3GPP only focus on option 2, option 3, and then option 4 and 7 added transient. So there are some options that were being dropped because of not I would say adopted by the community.
Great.
So
Great.
so we are here in option 1. Okay, so the community, the majority of the community and the industry believe that that's actually the transition that we want to have, right? That's the target architecture, that we have a 4G and then hop we have a 5G. Okay. But for sure, such a transition is not easy, right? It's very disruptive, huge impact on the network. You cannot just migrate network, migrate 4G to 5G. This is not always the case. That's why the GSMA and the vendors and most of the community are suggesting migration scenarios, okay, to guide the operators on how they do the shift from 4G to 5G. So there are a lot of options. There is one option fits all, right? But it's based on the strategy, based on the operator's design, current infrastructure. A lot of of aspects influence this direction. Each operator choose the best migration option. What I brought here, that I brought one of these options, okay, and I will show you on this map what will be actually the, I would say, the anatomy of movement from option 1 to option 2. So normally the first step, or the direction that we saw in the market, and this is happening already on many operators, that okay, they say, okay, we are in option 1. Let's introduce the new radio, and from coverage perspective, the new radio coverage will appear like spots in the big LTE coverage. Okay, so we are covering already the land with LTE, and we are already integrated with EPC. Let's add the new radio, and we have a flavor of the NSA 5G deployment. Okay, and in that case, we can make use of the boost on the user client side. So new radio can help us big time to to broaden the pipe and have more downlink, especially downlink. And in that case, they say, okay, if we do that, so maybe now we can cover the EMBB use cases, the enhanced or the ultra mobile broadband use cases. So we can have bigger data packages. People will consume data faster, pay more, and that's actually these are the first 5G deployments. They are all adopting option 3, and they are in particular adopting a sub option called option 3X that we will explain. And then they say, okay, we go from option 3 to option 2 in a way or another. Okay, but
so
yeah, please.
Yeah, thank you, Karim. Just to highlight, so as you suggested here, we are talking about the first option is moving from option 1, or the first journey, to option 3, while utilizing the EPC, the existing 4G mobile core, and maybe introducing some new radio or G Node B on some areas, maybe like the downtown, some area where the service will be requested and there will be demand for maybe enhanced mobile code. And as you mentioned, I remember when I first saw this slide, I was going to comment, if we are in option 3, is the existing EPC capable of providing all the 5G drivers or the 5G wishes that we are wishing to have, like ultra reliable, low latency, like IoT? I believe maybe not, like network slicing, maybe all this will not be supported, but we will be supporting some of the use cases, maybe similar to enhanced mobile broadband. Am I correct? Or?
Yeah, 100%, and that's one of the confusion that they're in the market. They say that when someone launch 5G, they say, okay, let's go for network slicing, but it's not like that. Okay, network slicing basically requires a standalone deployment, a 5G core. But in the option 3, we are just getting the benefits of having, you know, the eMBB, the gigabit experience. That's it. And for sure, it requires some enhancements from feature perspective on the EPC and on the LTE, on the HSS. They have to adapt to bring this option 3 architecture. So, but there are other transit steps, right? Yeah, and if you look to option 4 and option 7, and they exist in many of the operators, I would say, 5G deployment plans. They appear as a transit step from option 3 to option 2. And if we now go, for example, to option 4, it seems in option 4, for example, that either your EPC was able to evolve and to be upgraded to also have a 5G core capability. And you know, in the last session, we had some input from the vendors that there are some I would say potential for merging the capabilities this year, like having gateway UPF, having MME from 4G and MF from 5G. So it looks like that. And option 4 or option 7, the selection of the anchor point, that's something related to the I would say radio planning, related to the operator, some radio considerations, some coverage consideration. So option 4 and option 7 are all transient states, and you'll see even how 3GPP is thinking about that when I show you how the timeline for 3GPP, how they covered 2 and 3 and 4 and 7. And I see that we didn't talk about 5. So 5, I put it in dotted because 5, if you see the structure, so it's mainly the LTE radio is connected to the 5G core. So initially it looks like, at least for me, is you know, it's a little bit weird, right? Because so when I talked about that, when I searched about that, I found that there were some organizations like NGMN in particular. NGMN said, okay, we want to have option 5 because we believe that with the existing radio, if you had the new 5G core with the 5G capability in the core, this may add benefit or positively impact the LTE service. Okay, but from 3GPP side, I didn't see much focus on option 5. From my experience working with the operators, at least in the region, you know, I'm in the Middle East. I didn't see option 5 in the strategy, but it exists. Theoretically, it exists, and this was just high level. I see there are some questions. Redwan, if we can just take.
Yeah, I was going to take them one by one. Yeah, thank you, Karim. First one, maybe thank you for this. Is like a blueprint for everyone who want to any operator to consider the option of deployment. Is really clear. First question, is there a pass directly from option 3 to option 2? Did you see this in a market? Is anybody just going from option 3 to option 2 directly, or most of them they go through 4 or 7 and then 2? This is the first question, and then
I see there are some, there are options going from option 3 to option 3 plus 2. I mean, you will not replace option 3, but both will exist for a while. So it's going from option 3 to option 3 plus 2, and then gradually to option 2. Because, you know, turning off 4G, it's a very strategic decision, you know, it's not just a part of deployment plan. So turning off 4G, it's a very critical decision. So if you take this decision, then most probably you'll go for option 3 to option 3 plus 2, and then after a certain time, you turn off option 3 and you stay with option 2.
Another question, I think we touched base on it. Can we get the full speed of 5G in option 3 because we have the EPC as a core, not 5G core?
Yeah. Yes, theoretically, yes. This option 3X in particular is coming to fulfill this gigabit experience, because if you see from frequency perspective, radio perspective, there are two frequencies, right? The 5G and the 4G. So we are using the 5G spectrum, the 5G band for the downlink. So we are expecting to have benefits of the 5G band in the downlink. Okay, so yes, this option 3X covers the gigabit experience, and initially the first deployments was all for the fixed wireless access. So you have this dongle in home, or the wireless modem. So it came to cover this use case in particular. That was the first use case.
Another question is, are the cups still considered part of EPC, which is control plane separation? Yeah.
So the cups, which is the control and user plane separation of EPC nodes, was originally introduced in release 14 in 4G. So the cups is not a 5G concept. Okay. In the 4G, you had the capability by cups to split the P gateway to P gateway C and P gateway U, S gateway C, S gateway U, TDF-C, TDF-U. And then this was, I would say, setting the stage for the 5G, because the 5G having cups by default, okay? Because in the 5G, there are some nodes like the UPF, it's only managing the user plane, while, for example, the AMF and SMF are managing the control plane. So basically, in release 16 and release 17, if you are going for an ultra reliable low latency deployment or edge deployment, you just get the UPF user plane function and you put it on the edge. Yes, so the cups is there in 5G by default.
Yeah. Okay. And I believe also for EPC there are some enhancements. So maybe you will not have all the capabilities of 5G, but some of it. Yes. With existing.
Any other questions?
I think let's move to the next slide, and we will be touch base on the net slicing and with 5G.
Yeah. Okay, so keeping the same template and the same blueprint. Okay, if we see how the standardization is moving on forward, it's you know, 3GP R15. This is the release for the 5G. Okay, so release 15. It's the first release for the 5G, and it was frozen in, I mean, like closed in 2018. Commonly, they target March, but sometimes they slip to June. So if you see, there are some drops, like something like early drop, main drop, late drop. So in the early drop, 3GPP covered the specifications of option 3. So option 3 is 100% covered. And when you see a standard close the topic by Q4, or sorry, by Q4 2017, from my experience, you should always expect minimum 6 months to 1 year for any commercial deployment, okay? Because the vendors need time to absorb what we call stage 3, which is actually the bits and bytes and the frames and something like that, and start developing their solutions for a commercial product, and then going like for a trial or a POC with the customers. So it was frozen, it was closed at the early drop in Q4 2017. That's why we started to get a lot of announcements on 5G deployments starting by end of 2018 and 2019, right? So it's very aligned with the timeline from the standardization. Option 2 was introduced in the main drop, and that's the exact date for the release freeze, by covering option 2 in Q3 2018. I guess it was in June, okay? And then option 4 and option 7, which seen as a transit steps, was introduced in a late drop. So it was after the freeze date in Q2 2019. So again, if option 4 and option 7 were frozen or were completed in Q2 2019, then I don't expect, you know, any option 4, option 7 commercial deployments till Q3 or Q2 2020, which is
exactly this
the
year.
current time. And yeah, so this is how the 3GPP are covering the options. And again, I tried to give you some market insights. So there was one document published by GSMA, which is the mobile economy in 2020. I think it was released last month. So they are talking about 24 markets or 24 operators launching 5G. So that's the NSA option 3. And GSMA was clear about that's an option 3 deployments. And then option 2, there are some trials, some pilots starting this year. And again, this is very aligned with standardization flow, because you need, I would say, 1 year to have some sort of trialing or some sort of live deployments. So it's very, very recent. As you see, I got this from live trading. So that's the first standalone 5G deployment in South Korea, right? And it is only happening this year, okay? Because I just end my discussion here, that there are many dependencies, right? Not just the radio and the core. One of the main factors that impact the adoption of a certain technology, if it's an SA or NSA, is the handsets itself, okay? The support of handsets. And I was talking in the last session that there are some manufacturers like Apple, for example. When Apple delay the 5G support in a latest release, this impacts the operators and their willingness to do the 5G, and the other way around, right? Because if you see, for example, the initial 5G deployments in the Gulf, let me give an example. So they all started with the dongles, with the USB or with the home modem, and that was somehow okay. But most of the people already, they were enjoying, you know, fiber to home, FTTH, so they were already, you know, happy with their data. And when they went for smartphones, I mean, they want to give a 5G package coupled or linked with a certain smartphone, they found that in the market it was only the Android market, the Android phones like Samsung, LG, and the first one I saw was ZTE smartphone. But that was completely against or opposite to the market trend or the consumer's trend. The consumer's trend there is very, you know, concentric about Apple, right? They all have iPhones. So that was a block in the 5G spread, because people, they are not willing to change their habits and bring another smartphone, other Android, other than the iOS. So we have to work for the Apple. So that's why I'm telling that the handsets readiness is very, very important.
Yeah. Really, yeah. As in, even I remember, because I'm coming from transport. Usually, even if we are ready, what really matter is the application or the CDN ready, maybe for IP version 6. If you want to have something new, what really cares is the end user and the application adopting this new technology. Just a question came to my mind, Karim, again also. If we consider Rekaton, is it also completely option 2, or they are more into option 3 because they have also coexistence of some 4G?
Okay, in Rakuten, it was somehow simple to go, you know, innovative, because it's a green field. Yeah. So they relied on the OpenRAN or vRAN on both technologies in 4G and 5G. So both of them exist, the 4G and the 5G. For example, I would say they have a mix of option. Well, they started with option 1 because initially it was the 4G, and then now it's a mix between option 3 and option 2. But I don't think the 5G is still live there, so we have to wait and see, especially for the 5G.
Sure. Thank you. I think we can proceed to the next slide.
Okay, so I'm focusing on option 3 because that's the trending one. That's the most probably, if you are working on a vendor or on an operator and you are still exploring the 5G, so basically this will be the first step. Okay, so there are sub options in option 3. Let me first just to try to read what is the title here. So it's called ENDC. Okay, so E stands for eRAN, and N, that's the new radio, and DC stands for dual connectivity. So it's a eRAN, new radio or new RAN, dual connectivity. This means that simply, that's it. By the way, this is the terminology of the 5G, of the 3GPP. Okay, so this means that there's a dual connectivity. So there is a new radio and LTE, and the EN, having the E first. This means that the eRAN will always be the anchor point. Will always be the anchor point for control plane. And for example, if you see this 3 and 3A and 3X from UE perspective and the connectivity with the radio, the common thing, as you see, that the LTE is always the one having the control plane. This is the control plane. So the UE will still have the UU interface. That's the interface name between the UE and the radio. The control plane will always be with the LTE. But I would say, to give you the look and feel of the coverage, because this will always make a difference. Let me draw something. Okay, so as I told you, the 5G coverage will always look like spots in the big 4G coverage. That's one of the aspects of the 5G. We talked about that I think in session 1 or session 2, that when you go higher in the frequency, there is an impact on the coverage, right? So most probably you will have something like that. Commonly in any 4G deployment, you will have some sort of 4G deployment. Then you will have something like that. So you will have like a 5G coverage area. Sorry, it's the okay, and you'll always have okay. Does it make sense? Yeah. Okay, so commonly, if you are, let's go to the leader pointer again. So if you are a handset that's being covered by the 5G, okay, this means that at the same time you can have control plane with the 4G because you are covered with the 4G, but you have a user plane anchor point with a new radio. So you can use the 5G downlink path, for example, to get data. So this means that you can have this kind of dual connectivity, and mainly you need the 5G because you need the gigabit experience. So you basically need the user plane path. But if you are this not 5, it's G, sorry. But if you are in 4G coverage, okay, then you are a 4G handset that having the control plane with the 4G and the user plane with the 4G. Okay, so this coverage diagram will always be the case as long as you have 4G and 5G coexisting. So what is the difference between 3 and 3A and 3X? So
I want to comment here, Karim, also again. I believe the drawing you just did makes complete sense from business perspective. I remember in first session we talked about that we call it monetization, or how to justify spending this huge amount of money to build all this new radio and 5G. So maybe it doesn't make sense, and business return on investment will not be appealing for rural area, for small cities. So I believe this also happened in 4G, early 2010, 2011, and so on. When they started in urban areas, they started in the cities where they can get the business. So I believe even if technology, you want to deploy 5G everywhere, from business perspective, you want to be smart, where to start, what services to introduce first, and to make sure that the customer is willing to pay for this service.
Yeah, 100%, Radwan, you're right. And by the way, one of the advantages of option 3, it's that it had the least impact, even from financially, on the operators to introduce 5G. So even it is less, I would say, there are no like dramatic change. The well, in reality, you know, the business case for sure it is 100% required, but some operators they don't only look for a business case, but sometimes they look for the branding. Okay.
Yeah.
And announcing that operator X is the first operator to have 5G in the region. Operator Y is the first operator to have OpenRAN in the region. The branding is very, very, very important. Okay, especially in the region here. And this applies, for example, in voice over Wi-Fi and these kind of services that failed to bring the promised monetization, but still it is there for sake of branding, right? Exactly. So let's just quickly compare these options, okay, and then have some questions, because I see there are some questions. So
yeah, I'm going to ask a very good question.
So it seemed that option 3, there are no user plane bearer or interface or tunnel or whatever between the new radio and the EPC. So if we go for the downlink data, for example, it will come from EPC to this anchor point, and it either goes to the 4G mile or goes to 5G thing, but there is no way for EPC to communicate directly with a new radio. And there are the interface between the new radio and LTE, which is XN. It's a control plane and the user plane, where in option 3A, the user plane of XN between the two radios are not there. However, now we have some sort of direct connection between the new radio and the EPC, so the downlink can go directly to the new radio. And we will talk about what is the advantage of having that. And in 3X it's the most, I would say, flexible options, because the user plane from new radio to EPC exists, and the user plane between the new radio and LTE also exists. So the downlink data or path can take two forms, either go directly to the new radio, to the handset, or maybe to the LTE and then go to the XN. So there are a lot of options, and also we can touch that in this slide. But let me get a question and then we can go.
Sure. One of the question is regarding user experience. If we have a user already in the spot covered by 5G, and he start moving, or the mobility, and what will happen to the mobility and user experience hand over from 4G to 5G? This is first question.
Okay, this is a very good question. Commonly, if you have two separate systems, okay, or two separate cores, like 4G, 3G, 4G, 2G, 3G, 2G, and when you go from a coverage, for example, from 3G to 4G or from 4G to 3G, you have some sort of handover logic that happens, and some core nodes talk to each other, and the profile or the data of the customer goes from one node to one node. So there's a standard framework for that. The good thing about option 3, because the core is only one, so we are limiting this transaction, this handover. We are doing very minimal handover. So if you are in 5G, Let me give you an example. But let's talk about option 3x, because option 3x or option 3a, these are the practical options, okay? So if you are in a 5G coverage, let's have the pen, and then you have some traffic, so you are enjoying a certain service. Let's see, so the service flow is coming like that. So it's coming from new radio to you, right? That's the downlink path. And then for some reasons you moved out of 5G coverage, and then now you're under the 4G. Okay. So with no handover, I would say, complexity, the EPC, okay, will just change your user plane termination, your downlink termination, from the new radio to the LTE. Okay, and then the traffic will continue to go this direction. Okay, it's a very simple. It's what we call, it's just S1 path change. This interface is called S1. Okay, this interface is called S1. So when you go from 5G to 4G coverage, what the core is doing is just doing S1 path change with a very simple mini handover flow. Okay.
Yeah.
We are making use that it's only one EPC, but if you have 5G C and EPC, the handover becomes more complicated. And just to cover this point, if you are in option 3x, I will make use of this question to explain 3x. Simply, if you are in a 5G coverage, the flow will go like this, right? And if you go to 4G coverage, this means that this path does not exist anymore, right? You don't have any radio path between the UE and the 5G radio. So now there are two options, actually. Either traffic go to new radio and then go to LTE and then go to you, and standards also allow that, or you do S1 change from the EPC to the LTE. And that's why 3x gave more flexibility, and we liked it because it has minimal handover transactions, and it has different, I would say, flavors or modes of data flow in this kind of handovers.
100%. Yeah. The question also, the other question, Karim, what if, let's consider maybe 3A or 3X, if I'm a user here and for any reason I'm not able to get the 4G coverage, which includes the control plane. So this means as a UE, I will not be able to connect to the control plane. What will happen here? I believe it's similar to any 4G case. Yeah.
No, it's a very radio specific things. I mean, when you turn on your mobile, it scans available bands, available frequencies, and see the preferences and whatever, and you try to connect. If not connect, most probably he will go for the backup route. That can be 3G and 2G. But Radwan, in your handset, okay, there are something called UE mode of operation. Okay, and it has many attributes. Like, for example, are you a CS phone? Are you a PS phone? Are you like a PS or CS preferred? It's very multiple options. It all defines your behavior when you are attaching. So if you cannot, for example, if you are a handset that using CS fallback, so you are a handset that requires 3G when making a voice call. So if you cannot attach to 4G because of your settings, you will be forced to attach to 3G, to the CS network, because you need always to have a voice service available. So there are a lot of parameters that control the UE behavior in such a scenario.
Okay. Yeah, thank you, Karim. Let me comment here, because coming from transport again, when I see option 3 here, LTE is like a bottleneck, is working like a relay. So actually you are limiting all the new radio capabilities with this LTE because all the data but here with option 3x, I believe you have like multiple passes. So is there is it part of the standard that, as example, I can load share, like, multi-band? If I have a traffic, I can send in both in R and LTE, or I'm still limited to all the download traffic should follow single data plane?
Yeah, that's a very, very good point of view. Okay, in this scenario, the LTE, the LTE is called master node, and the new radio is called secondary node. Okay.
Yeah.
So the good thing that if you are in a 5G coverage, and that's a very important point, and there are it's related to how you can split the bearer. Okay. Yeah, for example, if we define bearer, it's like the pipeline, and if you have like a bigger pipeline, that you have a bigger throughput. So let me tell you a case that would clarify this point. If you have a downlink, if you are a 5G handset, and you are in a 5G coverage, so the downlink is coming to the new radio.
Yeah.
Right.
Exactly.
Imagine that if the new radio can split the one bearer to be a downlink in this channel and a downlink in this channel. This will boost the downlink speed, right?
Yeah, exactly.
And this is actually one of the good things, again, about option 3x. Thanks for raising this point, because that's a very, I would say, a very basic standard in concept in 3x, that you can have what they call the secondary node split bearer. So the secondary node can do splitting of the bearer, which you cannot do in 3a, and that's one of the good points of 3x on top of 3a.
Thank you, Karim. Another question, I think we touched base on the last session about the handset vendor support or roadmap for 5G. I believe you mentioned ZTE, iPhone is not ready. Shall we touch base on this now, or maybe on another?
Yeah. I can comment on that from my experience, but for sure, every time things are changing on their side, right? So the case is that Apple was a little bit reluctant in the beginning, okay, and it had some issues about Apple and the manufacturer of the chipset, okay. So as the result, the first wave of handsets didn't include Apple, but included ZTE and Huawei, and then after that, LG and Samsung. So the question is, the software model brand didn't faulty? Yes. And the question here, maybe people who don't know this point, that if you want to, for example, initiate a certain service like VoLTE, okay, the handset manufacturer will come to you and will ask you to certify that I am Apple. You want to launch VoLTE, for example, you are Vodafone Egypt, for example, you want to launch VoLTE, okay, these are the tests, do the test, certify. Me as an Apple will certify the VoLTE service from your end, and you will do the opposite side, you will certify Apple. Once it is done, then okay, Apple will enable the VoLTE in Vodafone Egypt, for Vodafone Egypt. Same in 5G. In the 5G, when you are introducing the 5G, the handset manufacturer certify the handset. So it's a little bit painful.
Sorry, Karim, I believe your connection is your connection got interrupted the last minute. Yeah, it's stable now. Yeah.
Yes. I'm using hotspot. So I'm using that. Okay, it is similar to VoLTE. That's an answering for Sham's question.
Yeah.
That you have all handsets must be certified in the operator environment, also to guarantee the commitment from the handset manufacturer, and to guarantee that they will do for you the package that fits to your 5G parameters.
Okay. I believe the last question from Mahmoud is, we discussed it, he just want to confirm that for the download traffic, as we mentioned, it will be from EPC to NR, all the traffic will go there, and then the split will be on the NR itself.
Yes, exactly. Yeah, the split is not happening. Yeah, most commonly not happening from the EPC. It will happen from the new radio. Yes.
Yeah.
But
Yeah,
but this is a very important point. But that's for one bearer, single bearer. But if you have two bearers from the EPC, one, for example, is IMS, is voice over LTE, and one is 5G, okay, the EPC will be able to split the two bearers, one to go to the 5G radio and one to go to the 4G radio, okay? I hope this is clear. So one bearer split is from the radio, but from the core you can have multiple bearer split. Bearer one here and bearer two there, okay? Hello?
Yeah, I think we can carry on, yeah. Please,
Yeah.
let's...
Okay, so we took much time here. So again, option 3X, that's the mainstream direction. That's where most of the operators are doing. Okay, so I'll just go quickly. This is just to show you that there are multiple migration options. Okay, and I picked to you the EPS, which is the Evolved Packet System, to NSA, and then from NSA3 to NSA3 and SA2. Okay, this is the I would say one of the migration options. And please, Radwan, tell me if we should run, because it's almost we have, I think, 5 minutes, right? Or do we have time?
Yeah, it's up to you, Karim. You know, if you have time, still we can extend another 15 minutes.
Okay, so it's up also to the participants if yeah. Anyway, so
yeah, we can carry on if somebody needs to drop because he's limited in time. We are recording the session and we'll share it later on. Okay,
so just quickly on from the moving from option 1 EPS to NSA3. After what we explained in the last 40 minutes, I think now we can interpret what is there in this table, right? So when we say that it's from a use case perspective, that EPS to NSA3 has a limited support for 5G use case, that's because it basically support the eMBB use case only, right? There is no 5G core, yes, because it's based on the EPC. There are some impact on the 4G because you need some adaptation from the HSS, from the core, from MMES gateway, right? And the good thing that you can still use the voice over LTE. You can use the 4G, right, for the other services. When you start to introduce NSA3 and NSA2, the impact now on the new radio and the LTE, you have a 5GC deployment, so it's an investment. But I want just to focus on these 2 points. Okay. So you have the 5G, you have the 4G. There is no interworking currently, as far as I know, in the standard from 5G to CS. Okay. Guys, can you hear me? Because I see that. Yeah, sorry.
Yeah.
So there is no something called CS fallback from the 5G. So 5G cannot fall back to 3G. Okay. So that's the first point. You have different flavors of voice, handling voice in such 3X and 2 option. It's either you fall back to 4G, so you get the voice over LTE, the one that you have always had in the 4G, or you can go for voice over NR, over new radio, which is still not, I would say, that mature in the standards. Okay. So the main point here that there is no CS fallback from 5G. It's either you go for fallback to 4G and you get the 4G the 4G VoLTE, or you go for the future roadmap for voice over new radio. Okay, that's something I think we explained. So now it's clear. So that's option 1. When you go to option 3X, you introduce the new radio. Okay, you have the XN interface, control plane and user plane from both radios, and you have always the anchor point with the LTE for the control plane, and user plane you can have for 4G and 5G. The catch here that most probably you will have 2 frequencies, right? The 5G and the 4G. So we will use the 5G band for the downlink, and in the uplink, most probably we will use the 3G 1800 band. Okay, so that's how the That's how the most of the operators are doing that. So using the 5G for the downlink and the 4G band for the uplink. Okay.
Okay. Yeah, just to confirm, Karim, a couple of questions quickly. That let's say we are now in option 1 and we want to go to option 3. So we're expecting to have this new radio. So I believe you touched base very quickly on it. I believe we operator need to invest to some enhancement on APC to support this new radio, especially this high bandwidth. And yeah,
True. And also investment on the LTE to support such an interface.
exactly. Yeah.
And some other features on the HSS. So it's a very nice mention in the GSMA. What are the options? What are the network functions impacted? Okay, and I'm sure colleagues here working on the vendor side or operator side, they know what I mean.
Another question came from Khalis is in case of option 3, where we have dual connectivity of 5G and 4G, can we still use CSFB?
No, CS fallback is not there. So there is no 5G to 3G CS fallback or 5G to 2G fallback. But if you are, but if you are covered in 4G coverage, okay, then all the 4G principles apply. But in the case of dual connectivity, the direction is either you go for voice over LTE, so they have the bearer through the 4G, or you have the voice over new radio through the 5G. But there is no CS fallback.
Exactly. This will remind me of when we discussed in the first session, because as you mentioned, 4G is all IP. So it's like packet switching, not circuit switching like the old 3G, 2G.
Yeah, exactly. And that's the case even for 4G.
Yeah, I mean, I was talking about 4G. 4G is an all IP solution. Yeah. I think we can move to the next slide.
Yes.
Yeah. We are running out of time.
So just like a view of the option, how it look like. That's option 3X and option 2. Hopefully by that time we will have some combined nodes. Okay, because if you don't have combined nodes, this means that you'll have more signaling, more transactions during handovers. Okay, and that's not a good thing. But majority of the vendors are doing that, or they have a roadmap to do that. Okay. Okay. I just have one slide, and I believe it is important, which is the vRAN and the cRAN, and because this is a very trending topic, I hope we can cover that. So if there are no questions, I can move to the.
Please proceed. Yeah, please proceed to the. Yeah.
Okay. So there are a lot of terms, right? RAN, cRAN, vRAN, ORAN, and I always say if the term is not clearly defined in a standardization body, it really becomes a mess, and anyone in the community can use it for special purpose. Maybe I can say cRAN, but I mean vRAN, and you can say vRAN, but you mean ORAN. So definition is very important. That's why I believe that in our domain, in the mobile broadband and the radio and the core, these kind of things on the mobile broadband, standardization is very, very important. Okay. So initially we started with something called traditional RAN. That's actually the 3G and 2G RAN. These are the tower that you see in the streets and in the towns and villages. So basically, what we used to see, we used some sort of antennas, radio heads or radio units, okay, antennas on the top of the tower, and in the tower, I would say in the bottom of the tower, you have something called BBU, baseband unit. This baseband unit, this is the, I would say, if we for example, having an OSI, model, layers, right? So this RRU will take only layer 1, okay, and the BBU will have the whole brain and the logics of layer 2 and layer 3 and layer 4 till layer 7, okay. So exactly. same in the radio stack. Radio stack is layered, okay. We have the physical layer, okay. We have the transport layer. We have the logical layer, like physical, MAC, RLC, and then we have the RRC, radio resources control. That's the brain of the radio. So we can say now, just for sake of explanation, that layer 1, the physical layer, somehow is there in the RRH, and the rest of layers are all in the BBU. Okay. Between these two entities, we had a protocol called CPRI. Okay, and CPRI is a very, you know, like level 1 thing, like electrical physical thing. It was there. Okay, and it was standard because there are some standards body doing specification for CPRI and for eCPRI. I think CPRI, it's common protocol for radio. I don't remember the I, but anyway, this CPRI has been always there. But the problem that this CPRI commonly connecting two parts from the same vendor, right? So there was no, I would say, clear validation or feasibility that this CPRI is real standard, right? Because if you bring a certain vendor and then he made some proprietary CPRI and he fulfilled the latency requirements between RH and BBU, you will be happy as an operator, right? You don't care a lot about standard interface when it is locally, internally in one vendor stack, right? So that's why when you read the new specifications about the new, innovative protocols, I like an expression that said that, okay, CPRI and eCPRI, they were standard, but each vendor has its own prescription. So the prescription differed, right? And if the prescription differed, then somehow it's not right 100% standard. So that was the case. And CPRI by that time fulfilled the latency requirements for 3G and 2G. And then there was a concept introduced by some vendors in the market. It was not real coming from standardization, which is the cRAN. So if I am seeing the cRAN, one can interpret cRAN with centralized RAN, and one can interpret with Cloud RAN. But it all started with cRAN, centralized RAN. So some vendors, I believe it's either Ericsson or Nokia, they had this idea of actually having centralized BBUs, okay, managing multiple radio heads, radio units, okay? So this centralized doesn't have to be virtualized, right? It can be still the legacy thing, but it is centralized. And then a new flavor of a C comes, which is the Cloud RAN. That was suggesting somehow that, okay, why don't we get this BBU, having it virtualized on some servers, but still this virtualization solution and the servers still belong to the radio vendor, okay? So you start to get deployments from Huawei, from Ericsson, from Nokia, based on their hardware and software stack. So it is virtualized, but it's not open, right? It's still based on their solution. And then with the evolution of CPRI, I think in 2017, to account for the 5G coming, they worked on the eCPRI, which is an enhanced CPRI, providing more nicer latency requirements and whatever. So basically, just to set the expectations, the eCPRI or the CPRI interface has three sub interfaces or three functions. The CU, the control plane and user plane. So it manages the control plane and user plane and transmission. Yeah. It has the synchronization, okay, the point-to-point synchronization, and it has the management stack or management axe. So there are three functions: the CU, control plane, user plane, the synchronization, and the management interface. Okay, so the eCPRI was an evolution of the CPRI. I think it was in 2017 released, and you can just write CPRI specifications. You'll find an entity called CPRI that include many vendors doing specification for CPRI and eCPRI. So that was the cRAN centralized and the cloud. And then we are in a phase that, okay, we said, okay, we have a Cloud RAN. So why can't we do it like a vRAN, a real vRAN? This means that it become the BBU or the centralized unit now. It's deployed based on COTS, based on Dell, HP, whatever hardware, and it can be still and based on Red Hat, Mirantis, whatever. So it is very open solution with respect to virtualization. So it's not coupled with a certain stack, okay? And at the same time, the vRAN concept with the evolution of ORAN Alliance and TIP projects and OpenRAN, new players came to the market, because when you start to make this part open, in the sense that you can have your own deployment on Red Hat, on Dell. So this encouraged many new players in the market to come, like Mavenir, Altiostar, right, Parallel Wireless, to come and provide a solution, okay? While the RRH was still a step that we are actually expecting at the end, because the RRH are still coming from the big vendor, mega vendors. So these new players came with an approach to integrate with third-party RRH. So they say, okay, we can work with Nokia, we can work with Ericsson, we can work with whatever, but on the condition that we understand or we agree on the ECPRI that supported by the RRH from the vendor. So it's always common to hear this term, that the vRAN vendor come and tell you, do you commit that the RRH vendor will open the ECPRI, that he will share the ECPRI? So they always need to have ECPRI, some sort of agreement with the RRH vendor on what version they will be using, what are the parameters. So this is only the I wouldn't say a blocking point, but any brownfield network introducing the vRAN will always have this point of discussion. Yeah. If the RRH vendor will accept to work with the new vRAN vendor or not. Okay.
Let's comment here something, Karim, we discussed before with me. I believe one of the major revolution to make this possible and happen is when we were in traditional RAN and moving to cRAN, the introducing the Ethernet. So when we were able to have Ethernet as a protocol between these two, which it's standard, simple, and everybody can use it. This make it easy for to move from yeah.
Actually, from the evolution of the ECPRI, and when you go to xRAN, Ethernet is one of the options. Yes.
Yeah.
Okay,
but it's one of the main thing that make it more easy for many vendors to join, to come and play in this area, vRAN and ORAN, or do you believe it's not a big
No, it is one of the enablers, because once you simplify this ECPRI stack, okay, you encourage more players to come, even in the RRH arena, not only on the BBU or on the vRAN side. As you have noticed, till now, this is not coupled with 5G, and that's again one of the or one of the confusion points that there in the community, that vRAN or cRAN or ORAN, even ORAN, is not a 5G technology. Okay.
Exactly.
Maybe it can be one of the enabled, but it is there in the 4G and 3G. Okay. And actually, the first deployments for these new players in Africa, in Peru, in these kind of things are all 3G, not even 4G. Okay. So the concept is agnostic to the radio access technology, and then what we are targeting and what the initiatives are doing is to go to this stage. Going to this stage of the ORAN or the OpenRAN, that it's a framework that allow multiple vendors. You can have, for example, if we start to map the 5G radio components, for example, this is called RU in the 5G terminology. Let's say that this is called DU, distributed unit. That's a CU. Okay. So the promise is that you can have CU from one vendor, DU from one vendor, RU from one vendor. The application itself can be an open source. So it can be, for example, like Facebook core project Magma, right? Like to have it as software. To be open, like for example, can run on Red Hat, run on VMware, run on any infrastructure as a service, can run on COTS, okay, not specifically to a certain hardware, and introducing this cRAN as an open interface. So the cRAN, formerly there was one group called cRAN Forum that had the operators, okay? And if you compare the cRAN to eCPRI, okay, there are a lot of similarities, but one of the main differentiation of the organization itself, eCPRI are a legacy way of doing standardization, bringing vendors together, right? But cRAN is coming from the operators, and that's where the innovative starts, right? Even in the NFV and the orchestration and these kind of things. So there's like Verizon, AT&T, and all these operators. So the cRAN, when you see the specs of the cRAN compared to the eCPRI, I would pick one attribute to talk about because I think it's important. So cRAN, for example, it is suggesting to have netconf APIs for the management plane. And that's a very, it's a dramatic change. eCPRI doesn't have anything about APIs, right? For the cRAN, the management plane is realized via netconf. If you go to the cRAN, you find that there are two variants. There is eCPRI and something called ROE, Radio over Ethernet, which is something coming from IEEE. Sorry, from IETF. Sorry. So there are some differences. So we believe that this is the future, going to cRAN. And if you really achieve open interface, then خلاص, even the RU can be open for new vendors, right? To having like some sort of white box solutions, right? So imagine the impact of that on the capex and opex for the operators. For sure, it will be a very competitive solution. It will give really big hard time for the legacy radio vendors. That's why we see, as we said in last time, that even radio vendors like Ericsson, Nokia are now joining these initiatives and participating.
Yeah, let me comment here, Karim. Yeah, so you're right. Yeah, it's like a nirvana, which we wish we can live and see. But usually, as all these new disruptive ideas, there will be some resistance from the big player, especially for the RU piece, which is, as we discussed before, this is the most of the revenue coming from there. So at the beginning, there will be some resistance, but then they will have to join because this is the business trend, and operator, the customer are pushing them to be part of it. So hopefully by the end, we'll reach this phase. And as our colleague Mahmoud, he mentioned a comment, which is Muhammad, sorry, which is always whenever we have this multiple vendors and multiple layers, interoperability and compatibility matrix between the three will be always a challenge. Yeah. Maybe if you want to comment about this.
Yeah, this is a very, very important question. And also there is another question about the latency, because I know that latency figures are very important. So let me answer the latency first, and then I'll go for the compatibility matrix. So yeah, the latency from CPRI to eCPRI for sure changed, because this was serving like 2G, 3G, and that was serving mainly 4G and 5G. So it is different. But to give you some hint about the latency figures, for example, in the 5G, okay. So the RU DU, okay, the RU DU, and that's the front hauling, right? In the expression, it's like microseconds, from 100 to 200 microseconds, okay. And these are like the market figures. Maybe they can go less or high, but that's the average, from 100 to 200. We'll not be able to do the micro here, right? Okay, so that's the front hauling, 100 to 200 microseconds. The DU to CU, which is mid hold, the latency figures are somehow relaxed. They are in average of 50 milliseconds. Okay, so this for sure impacts the decision on where to place these components. Okay, and it makes sense for 5G, because most probably if you want to go, for example, for an edge deployment, having the CU and DU somehow deployed on an edge DC. So these latencies must be preserved. That's why I always say that before you start doing any RAN, ORAN, vRAN, you have to do a proper assessment for your network, do a latency end-to-end, to see exactly where are the locations, where are the POPs that are going to hold these. The other question about the interoperability thing, yeah, I totally agree. But the good thing that this open initiatives like the ORAN Alliance, like the TIP project. The good thing that they try to build the ecosystem, okay? So they eventually they will be able to give you some sort of stack certified and verified with each other. Like this component is certified to work with this component. Maybe it's not strictly like that, but let me tell you, for example, one example. Okay, in the CNTT under Linux Foundation and the GSMA. This entity is working on the infrastructure, okay, and they also have working also with OpenNV, which is somehow doing testing and validation, certification. So imagine that if this entity cooperated with the ORAN, and then they bring the VNF, for example, of the CU, and then they deploy it on a certain stack, open source stack, based on OpenStack, based on Kubernetes, based on whatever, and then go to OpenNV to certify the stack. So that you as operator, you see, okay, this is a CU, and this is the NFVI stack, and it is certified by this community, so I can trust that I can put this CU on the NFVI. So that's tick, right? From the ORAN perspective, they should do some pilots, POCs, merging multiple RUs with multiple DUs, and then getting them certified, so that you as an operator, you get I would say confident. But again, at the end, and if you are working, I'm sure in the mobile domain, even in your network, you have to run the interoperability testing at your environment. So you will do it anyway, right?
Exactly.
Even it was peer like radio talking to core, one from X, one from Huawei, you have to do the interoperability testing. You have to do the multi-vendor integration testing. So the testing will be there in the operator side, but before that, we will have some sort of certified stacks with these from these open source initiatives and organizations.
Thank you, Karim. I believe this is the last slide, so let's open. We have almost 5 minutes if we have other questions. So today, I believe it was very fruitful session as usual. Thank you, Karim. We discussed the deployment options, option 1, 2 till 7. We talked about some migration paths and what are the things which Karim actually experienced in the field and with other operators. And finally, we touch base on the evolution in the RAN, cRAN, vRAN, and now the promise of ORAN. So let me see if anybody has any question in the chat. Nothing so far. Even if you want, just unmute yourself and ask the question, just if you wish. Thank you, Karim.
Okay.
So that's it. Let me stop the recording. Yeah.